Hello, this is Scholar Strive doing some math today. In Algebra 2, we're going to be looking at the probability of disjoint and overlapping events. A compound event is the union or intersection of two events. So we have event A and we have event B. If it's a union, then everything gets shaded. Means both events can occur, and either one event can occur, the other event can occur, or both can happen at the same time. And this would be denoted as A union, so they use a U, B. Or we have, and we also, for union, we use the term or. So A or B, or A union B. And then we have the intersection. Here's A, here's B. The intersection is just this piece in the middle where they overlap. And this is denoted as A intersect B, which is an upside down U. And they use the term and. Well, just parentheses. So if it's an intersection, it's A and B. If it's a union, it's A or B. So overlapping event occurs when A and B share its outcomes in common. Disjoint or mutually exclusive events. They occur when A and B have no outcomes in common. So disjoints are not connected, and what that would look like is you have A, you have B, no overlap. They're just separate. Two events that can't occur simultaneously. Like the event of getting a good grade in like say, yeah, getting a good grade in algebra. And then the event of getting a bad grade in algebra. You can't have both at the same time. Well, I guess possibly if you retake the class, but then that's a different story. Probability of overlapping events. So the probability of A or B, okay, which is the same thing as probability of A union B, this is equal to the probability of A plus the probability of B minus the probability of A and B. Oh, we're doing versus. Okay. Let me make this a little bit smaller. Probability of A intersect B or and B. And then disjoint. If the events are disjoint or mutually exclusive, then it's just probability of A plus the probability of B. So if you didn't understand what a mutually exclusive event is, another example would be you're drawing from a deck of cards, and what's the probability of drawing a jack of spades and a jack of hearts? You can't draw both from one standard deck of cards. You can either draw one or the other. Which makes them mutually exclusive events. The complement of A, it's denoted A with a bar over it, or sometimes you see it as A prime, or A to the negative first. Sometimes you see it like that as well. Just depends on what you're doing, but we're going to be using A with a bar above it. The complement, the probability of the complement is 1 minus the probability of A. So basically, you want to say it's considered, if you're looking for the complement of A, it's not A, basically. So the probability of drawing a jack of diamonds, for example, is 1 out of 52. The complement of that probability, so the complement of that probability would be everything but drawing the jack of diamonds. So what I'm saying is every outcome not in A. So let's say this is my sample space here. Here's A. The complement would be everything outside A. So let's go through some examples. A card is randomly selected from a standard deck of 52 cards. What is the probability that it is a 10 or a face card? Okay, so they use the term or. Okay. So we're looking for the probability of 10 or face. So this is equal to so first we need to figure out if these events overlap or not. 10 is not a face card, so you either draw a 10 or drawing a face card does not mean you draw a number 10, and drawing a 10 does not mean you drew a face card. So these are disjoint events. So my formula is just the probability of drawing a 10 plus the probability of drawing a face card. Probability of drawing a 10, there are 4 10s out of 52 cards in a deck. And then we're going to add the probability of a face card which are, there's Jack, Queen, King, face card is Jack, Queen, King, so that would be 9 out of 52. 9 out of 52 are face. So this will be 13 out of 52, which is 1 over 4. So you have a 1 in 4 chance of drawing a 10 or face card. What is the probability that it is a red jack? Okay, so the probability of red jack is, there's only 2 red jacks out of 52, so 1 out of 26. What is the probability of a face card or a spade? Okay, these are not mutually exclusive events. They are not disjoint, because you can have a face card that is a spade. So it is the probability of a face card, drawing a face card, plus the probability of drawing a spade, minus the probability of drawing a face and spade. Okay, so the probability of drawing a face card is 12 out of 52. Plus the probability of a spade, there are 13 spades. And then we're going to subtract the cards that are both face and spades. So that would be the Jack of Spades, the Queen of Spades, and the King of Spades. So there is 3 out of 52. Add this all up, we'll get 22 out of 52, which reduces to 11 out of 26. So that is the probability of drawing a face or spade card. You roll a 6-sided die, find each probability. Rolling a 2 or a 5. These are disjoint events because you can either roll a 2 or you can only roll a 5. You can't roll both if you're only rolling it at once. So the probability of rolling a 2 is 1 out of 6. The probability of rolling a 5 out of 1 out of 6. You add them together, you get 2 out of 6, which is 1/3. Probability of rolling less than a 3 or an odd number. Okay, so that is equal to probability of rolling less than a 3 plus the probability of an odd number. And since they both can occur at the same time, we're going to subtract where they overlap. So less than 3 and odd. Probability of less than 3 is just 2 and 1, so that's 2 out of 6. Plus the probability of odd, that's half the numbers, 3 out of 6. And there's only one time where it's both odd and less than 3, which is rolling number 1, which is 1 out of 6. And this will become 4 out of 6, which is 2/3. Out of 200 students in the senior class, 113 students are either varsity athletes or honor students. 74 seniors are varsity athletes, 51 are honor roll. What is the probability of randomly selected senior is both varsity athlete and on honor roll? So we're looking for the probability of varsity. What's the probability of randomly selected senior is both a varsity athlete and on honor roll? So our goal is to look for varsity and honor roll. Okay. Now we have a formula that says if we are looking for probability of varsity or honor roll, that is equal to the probability of varsity plus the probability of honor roll minus the probability of varsity and honor roll. So the probability of varsity or honor roll is 113 students out of the 200. Probability of varsity is 74 out of the 200. Plus the probability of just honor roll, which is 51 out of 200. Minus what we're looking for. So I'm going to get 113 out of 200 equals 74 out of 200. Or no, not 74. Adding 74 plus 51 is 125 out of 200. Minus the probability of V and H. So the probability of V and H would be 12 out of 200. So I just subtract 125 over and then divide both sides by -1, and I get 12 out of 200, which reduces to 3 out of 50. So the probability of randomly selecting a senior that is both varsity athlete and on the honor roll is 3 out of 50. Alright, you roll 2 six-sided dice, find each probability. So find the probability of the sum that does not equal 6. Okay, so that would be the probability of basically that would be the 100% minus the probability of the sum equaling 6, which is 1 minus 5 over 6. And then before we go back to that, it's best we make some sort of table. Insert page. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. When we roll 2 dice, we can roll 1 and 1, which would give us 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. 2 and 2 is 4, 5, 6, 7, 8. 5, 6, 7, 8. 6, 7, 8, 9. 4 plus 4 is 8, 9, 10. 10, 11, 11, 12. So those are all my different combinations. Okay. So instead of finding where all the numbers where the sum is not equal to 6, we're just going to take from the 100% and minus all the sums that are 6. So 1 plus 5, use a different color to circle these. So 1 plus 5 is 6, 2 plus 4 is 6, and we got 6 here, 6 here, 6 here, and that is it. So this is 1, 2, 3, 4, 5 out of 1, 2, 3, 4, 5, 6 out of oops, I think I messed up. Oh no, I got it. Yep, that's right. 5 out of 36 combinations. Alright, so let's go back to here. 5 out of 36. Which is 31 out of 36. Alright, part B, the probability of the sum being less than or equal to 9. Okay, 1 minus, so this would be okay. So this would be the same as 1 minus the probability of the sum being greater than 9. Okay, so this is 1 minus. Okay, let's look back at my chart again. So we're looking for sum greater than 9. So that would be this one, this one, this one, this one, and this one, and that one. So 1, 2, 3, 4, 5, 6. So 6 out of the 36 are greater than 9. So this will tell me how many are less than or equal to 9. 5 out of 6. That's the probability when you roll 2 dice of it being a sum less than or equal to 9. There are 10 people at a dinner party. What's the probability that at least 2 have the same birthday? Okay. The probability of at least 2 having the same birthday is equal to 1 minus the probability that none have the same birthday. Because that would be easier to calculate than calculating 2 having the same birthday, 3 having the same birthday, 4 than 5, and so on. None have the same birthday. So how do we calculate that? So that is 1 minus well, there's 365 days in a year. Okay, So the probability that none have the same birthday goes like this. The first guy has 365 choices for his birthday, times the second guy, which is 364. He'll have 364 days if we're going for none having the same birthday, times 363. That's the third guy. Then the fourth guy, 362. Fifth guy, 361. 360. 359 times 358. And then the 10th guy will have 357 days to choose from, all divided by 365 to the 10th. That's the total total amount of total combinations of, like, say, hey, this guy's January, out of the 10 people. So, like, for example, one of those choices would be everyone was January 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. Another choice would be this first guy's January 1st, other guy's February, then March, April, May, June, July, so on and so forth. All those combinations add up to 365 to the 10th power. You definitely need to use your calculator because you'll get 1 minus 0.883, which is equal to 0.117. So there is a 11.7% chance that two people will have the same birthday. At least two. Which is a lot higher than you would think. I mean, it's still quite low. Probably won't happen. There are 500 different messages hidden inside fortune cookies for a particular company. What is the probability that in a group of 5, at least 2 receive the same message? Okay, the probability of at least 2 get the same message is equal to 1 minus the probability that none are the same. So 1 minus, okay, there's only 5 people, so the first person gets 500 choices, then the next person gets 499, then 498, then 497, and 496. And then there's 500 to the 5th choices. Total possibilities is 500 to the 5th. So we have 1 minus 0.9801. So which is 1, or not 1, 0. Oh. 0.0199, which is equal to 1.99%. So pretty much almost a 2% chance of at least 2 people receiving the same message in these fortune cookies. Hopefully this helped you out. Have a good day.